Thank you, everybody, for being today at Java 21 and beyond and listening to my talk. I'm a little nervous because of the location and the amazing audience. However, I hope to tone it down throughout the talk. So, my name is Anna. I'm currently working as a developer advocate in the Java team at Oracle. I'm passionate about working with Java and with Kubernetes. So these are my two passions. I love to combine to create different projects using both in general. You're going to see a project today also with some examples that you can, of course, take further than I did. And yes, I'm really, really anxious of getting your questions at the end of the talk. And let's start with something inspirational, because I want to tell you that this presentation aims to give you details on certain features of JDK 21, to also look a little bit into what is there proposed to target to JDK 22, all to inspire you to build the future of your applications with those features. You should get to know how to get more value out of these features and to prepare the evolution of your applications. That's my aim for today. So probably many of you are familiar with the 6-month release cadence of Java that has changed for quite a while. In the beginning, it was a little bit surprising because, well, every 6 months instead of every few years to get a Java release. The advantage of this new type of release is that you get smaller chunks of features that you can try, that you can give feedback on, the preview features, the incubator features. You can give feedback and say what's going on within your project if you would adopt those features. So it's great from that point of view, and it's easier to learn than waiting for a couple of years that get a bunch of features and then get a couple more years to master them. So it comes a little easier to master them gradually. But some of these features, they come as belonging to different projects. And in JDK 21, some of these projects got features. Project Panama is not going to be covered by my talk today, but we can talk about it after it. Is aiming to improve the connections between Java and the native code and to give you a better way to interact with native code without using GNI, but a model, an API that is more close to Java, so don't have the extra middleman of GNI. Secondly, Project Valhalla is very much weighted, but didn't get features in JDK 21, but it's discussed, active, and everybody waits for it. Is Project Valhalla is augmenting the Java object model with value objects, and it will combine the abstractions of object-oriented programming with the performance characteristics of simple primitives. We had some features in Project Loom that got finalized, like virtual threads, briefly talked today as well, for scaling your applications. Leiden, again, is a very, very discussed project to improve the performance of your application, to improve the startup and the warm-up of your Java applications. It's a talk project. ZGC got features in JDK 21 with improving the scalable low latency garbage collector that was delivered in JDK 15. And last but not least important, Embark, that is giving you lovely Java language features that you would love to put in your code, that you use in your code, that you improve your code, making your code more readable, maintainable on the long term, and yes, probably sometimes less boilerplate. So without further ado, let's talk a little bit about beginning with Java. And when we talk about beginning with Java, usually we need a few ingredients. We all learn it in university, that you need a JDK. Ideally, you would need an IDE, but some of us have started with Notepad probably, or Notepad++ as well. A build tool, if you want to build a project, like a more gradual project. And of course, some code, some Java code. But most of the time, this Java code, this hello world that you see here, it contains a lot of keywords. There's a class declaration. There is the string args parameter that is declared there, but is not further used in that system out print hello world. So it's quite a lot for a minimal Java setup. And thinking about towards a simplified beginning, there were a few things that were done throughout the years. So there was first JShell to help you fast prototyping Java code. Then since JDK 11, you can use Java Hello World Java, so you don't compile and then Java the bytecode and so on. So you get these features. But also, to improve the launch experience, for JDK 22, JEF 458 proposes the ability to run a program that is given as multiple files, like in this case, hello world and helper, with just saying Java -- class pass everything, and yes, it will work. So you can also find the JEP, because everything that has underscore, it contains a link, and I'll give you the slides afterwards. So this is the part with the launching, well, like simplifying prototyping and launching your code. However, we can do it better. We can simplify things even more. How about if we don't necessarily make it mandatory to have the class declaration anymore? How about if we're not using necessarily public static for the main? Because maybe we just want to code one class with a little logic in it and just try it. And how about removing those string args if we're not using them further, if we're not processing any arguments? So why have them there? So the first one, the hello world.java, now has the simplified way of working with void main and helper.run. So no need for class declaration of hello world to run it. And then comes the question. Okay, so if I declare multiple mains, what do I do? Which one is first going to be seen? The one with public static void, this one with void main, which one? So the invocation order is as follows. First of all is the one that we already knew, the public static void main, but also like the one that usually that doesn't have non-private accessor is going to be the first one that is going to be invoked. It's declared. The second one that is declared is the static void main method with any accessor, like the one without any string args, but with any accessor that is declared in the launch, in a non-private accessor declared in a launch class, is going to be the second one invoked. Third one, if there is a void main string args with any non-private, that's going to be invoked there. So if you take out the static, that one is going to be the third scene. And lastly, the void main, the one that we saw earlier, is going to be invoked there. So if you can try like having 4 of these and see how's the invocation order of each, and so on. This feature was a preview feature in JDK 21, so you have to use the -- enabled preview to work with it. However, gets another round of preview in JDK 22, so you still have time to try it and give your feedback upon it. And a few more links on how about this feature, videos, and so on that you can try on. But let's go to something a little bit more complex, because our applications are not usually hello worlds, right? And not just a few lines of code. So let's look about modeling our application. Records throughout time have gone through several changes. Records are transparent carriers for data and have suffered a few changes. And you can see in the slides that prior to Java 16, you were checking the type of a record, you were getting, instantiating that type, and using that variable, local variable, further to access its field. As of Java 16, you can just check the type of the record and then use it directly there. So no longer need the extra steps of instantiating and casting and so on, because you're certain that you're using that type of record. Moreover, as of Java 21, you can get access to the record's inner parts directly if you have declared this here. So when you're using this kind of instantiation, when you're checking the intention, for example, of the present, you can just go directly to its fields, the price, and just access them. So that's pretty interesting. But those are quite a lot of, there's quite a lot of code in the slides. And probably some of you are wondering where this is coming from. Well, let's go back a little bit. This is coming from an example where we're going to look at data modeling this. So how I data modeled this. It's the wrap-up application that I did for the JVM event in December. It has a few requirements. So this application has the following requirements. There's a person, a sender, that wants to send a gift to someone. And you can send a postcard with something more meaningful towards it. And usually when you give a gift to someone, you buy an online experience, you buy a coupon for a different retailer, or you buy a physical present. You box the present. The box can also cost something. These are different traits of your, let's say, logic, of your business. So we're going to model such an application that receives a JSON from, let's say, somebody saying, I want to send a gift to a person, to a receiver, and I want to be able to send a postcard together with a coupon, an experience, or a present, but never send 2 postcards as a gift. So this is the class diagram of that, how I modeled that. And we're going to dive into each of those and see what each of those represent. First of all, I'm receiving JSON. I'm then replying with the JSON with the entire gift situation that's going to be given to the sender, right? So since I am going to reply with a common format of JSON, I thought that maybe I can model this, the common formatting process, I can model it in an interface. And since all the coupon, postcard, experience, and presents have similar traits, they're belonging to the gift part, they can all become there can be intentions in themselves. If I need to add something different to my gift intention in the future, I can just add it here to the permits and make sure that my model is looking over to this. It's not like opened to everybody for implementing. So I can constrain a little bit my model for future implementations and make sure that people are not misusing this interface. So this is where my JSON is going to be modeled. Then coupon, experience, presents, and postcards, I model them as records. Because, well, I receive a JSON, I need to process that in something meaningful to my business logic. I'm working with coupon, experiences, presents, and postcards, and then I'm returning again a JSON. I don't want to work with a JSON all the time and go through string concatenation and parsing and all that. I want something meaningful to my model. And then, because the gift can be a postcard and an experience, well, I want for that to be meaningful, and gift contains nested record patterns, which can be postcard and coupon, postcard and experience, and so on. So here's an example of working with the nested record patterns of gift. As I said earlier, gift of postcard and experience in the instance of, I can go directly and have access to my experience currency just by declaring it like this in the nested part. So if we want to extract the experience, the currency of the experience, we can go it like this. But furthermore, if I just want to go and get the currency directly, I don't need to just say the experience and then say e+point.currency. I can just say experience has the currency C, and I have access to the currency, also as of JDK 21. And last but not least, since I'm not using anything else except currency there, I don't care about that type, the other type. So I'm using var for the other record types or for the other fields within the nested records. If you want to know more, here are a few links. No need to take a picture now. Will be shared at the end. So let's move a little further. I'm processing JSONs, and I'm replying with JSONs. There are libraries that can help me to work with this. However, it would be great if I could do this processing a little bit more closer to the platform. And since this common formatting process is common, why not use templates, string templates? String templates complement Java's existing string literals and text blocks by coupling literal text and embedded expressions and template processors to produce specialized results. So, how a string template looks like. Now, a simple string template that would just take strings and that would take text blocks, actually, in this case, looks like a JSON there, right? And then returns a string would look like this and has a few components. A template processor, str, this is built in the JDK, so it's given. A dot character, and of course, last but not least, a template which can contain an embedded expression, like for example, the celebration, which is an enum. But this is very basic. JSONs maybe need further processing. So in that case, when you want to implement something a little bit more complex, when you want to check what you're receiving and you want to put your own exceptions on data and see what's going on there, you can implement the string template processor interface to make your own processor for your templates. I gave a little example of the template here, how the intention for the JSON is modeled here. I know this is very simple and it doesn't contain all the security part that normally comes when checking the input, sanitizing it, and also from serialization point of view, that would not be pretty unsafe. But this is just for clarity and example, because otherwise there would be too many lines of code there. So it would not be necessarily my end goal. However, just to give you a flavor, I defined this in my interface and used it further in having the common formatting process. So once I have this JSON, I can use it further in each of my records to give them a formatting way and have a JSON there, like for example for the present, and put it there. So once again, I have the template processor, the dot character, and of course, the template. And then you template, you can choose whatever. You can have expressions. So I put this template specifically in order to see the ternary operator there, so it can work with that one as well. If you want to know more, there are a few videos, and of course, discussions and the JEPs themselves about how string templates work. There were first preview in JDK 21, they come at second preview in JDK 22. So we have now records, we have a formatting process, but we need to, let's say, put some operations into process, like for our JSONs, because we need to process requests, but we cannot serve them randomly, right? So we're going to use pattern matching for switch in this case. And there are many flavors for pattern matching for switch. Because, well, you can use them to expand the expressiveness of the switch expressions with statements by allowing patterns to appear in case labels. You can also process nulls in the case, so you can use the case null situation, which, historically speaking, was not that much possible. But I think the most important part is that they augment the security of the switch, and they have backward compatibility with all existing switch expressions, which is very important. So it doesn't alter what you already defined in your previous versions of switches. What changed in JDK 21? In JDK 21, you have no more parenthesized patterns in the switch expressions, but you also get an extra to working with qualified enum constants. So for example, font in my case is a little bit more complex enum that is checking that it has a style and a color. So you can go and have an exhaustive switch over the font and have situations when you are checking more in depth your enum. So before JDK 21, you can use the qualified enums when you are doing the wins over there. So just an example for this. Furthermore, since we're talking about pattern matching and switch, if I want to process the present based on the choice that the person has, that would, and of course, bearing in mind my initial requirements, that's how the process method would look like. So it will be a lot of cases, because I want for my switch to be exhaustive. The reason why I want to do that is because I want to handle each of the requirements that I have and make sure that I'm not, bulking all the other cases of my requirements to a default branch and maybe introduce issues for my future requirements. So in this case, I'm treating each case of my requirements independently, and I'm ensuring a proper processing of my business logic. If I would add a new one, then I have to go to the switch and add a new case. It's much better to capture all the time, make sure that you're extending your application logic in an organic way. If you want to know more, here are a few links that you can use. And there's a link also to a recent discussion that happened on the JDK mailing list about uniform handling of failure in switch. This is very interesting for you to read about handling exceptions in switch expressions. But that switch that we saw earlier, the last one, was quite quite with a lot of cases. And the thing is that it's common for programs to only need some of the components for further processing, right? And we want to improve the code readability over time and the maintainability. And yeah, so in the case of my previous switch, to improve the code readability and of course to lower my error chances, what happens is that I have the option of adding a named, to add underscore for the variable names that I'm not using later on the right side of my evaluation of the case. So wherever I don't need anything, I can just put the underscore. And you can see the three cases that were earlier, they got together with a comma there, and there the code becomes a little bit more readable. So give it a try. It's really fun to have the code compacted like this when you don't need furthermore those details. Now the good thing about this change is that it was delivered as a preview in JDK 21, but will be finalized in JDK 22. So it's all good. Another great thing that came as final in JDK 21 were sequence collections. And of course, JEP 431 is the one that talks about sequence collections. The reason why sequence collections were introduced is because, historically speaking, Java's collections framework was not having a collection type that was representing a sequence of elements with a defined encounter order. So it also lacked a set of operations like for that was applying uniformly across these collections. For example, list and deck, they all have a defined encounter order, but their common subtype, which is collection, doesn't. And this is an example that I have here, a small example, like defining the intersection of two lists. When you're going to get the intersection of two lists, you're all the time comparing the first element of the first one, getting compared the last element of the last one, and all the time working with indexes. Then, of course, looking at the last element of the first one, last element of the second one, all the time doing this thing like list point size -1 to get the last element. We kind of grew up with this mechanism. We know there was not something better. But with sequence collections, we don't need anymore to worry about getting the specific index for the first and the last. And that's because the sequence collection is a collection which allows you to have first and last elements, but also to have the elements in between successors and predecessors. So also this sequence collections types supports common operations at either end. So that's very important for you to know. And you can process the elements from first to last, and of course from last to first. So the program that we saw earlier becomes something like this, where you have like list get first and list get last, which is much more nicer to read than all the time getting the indexes and remembering the index, which was for the first, which was for the last, which was the first list, and so on. This is just a simple example where you can apply this, but also the fact that you have now built-in reverse is very helpful, so you don't really need to think more about how you're going to reverse the elements in a specific list when you have those requirements. If you want to know more, there are a video, a JEP Cafe, an Inside Java JEP Cafe, and a podcast, some of them with Stuart Marks, the author of the sequence collection JEP, detailing more about sequence collections, pitfalls, and things that you need to take care of when working with them. This is just a core lib change. Now let's go to the performance changes, because there are a few as well. Now in terms of performance enhancements, I'm going to briefly touch the garbage collectors one. Now historically speaking, ZGC, the Z garbage collector, was there in the JDK, was delivered in JDK 15, was finalized then. And is a scalable low latency garbage collector that can work with large heap sizes. That's its best threat. But this garbage collector should have been evolved to become generational as well. What that means is that this generational type of garbage collector would take advantage of the weak generational hypothesis, which poses that the most that most objects become unreachable shortly after they have been created. So what this generational ZGC does is frequently scanning the young generation, determining those that should have a short life, and of course, becoming more efficient with CPU resources. Starting with JDK21, you can enable it, so the generational part can be enabled with a specific flag, with the -XX plus generational, but you can also use the non-generational part as well if you want to use that one as well. Usually you start with the non-generational part and you tune to the generational to see what's the improvement, if there is any. Another change regarding garbage collectors, but this one is coming in JDK 22, is regarding G1, GC, but also about latency. So historically speaking, when you were working with GNI had some functions that are listed there, some of them actually are listed there, that get access, that give native code access to the Java object heap. So without requiring for this code to be copied. This was powerful, but also meant that you need to think how you're going to garbage collect this, because, okay, GNI getting access to the Java object heap, those should be preserved there for a while you need them, right? So what people did sometimes, people did when they used G1, GC, was to disable the garbage collector temporarily, thus increasing latency, with disabling the entire garbage collector for the entire applications to think so. Now with JDK 22 and JEP 423, what is proposed is to have region pinning for G1, GC. So it means that those regions of the heap that are being accessed by the GNI functions will be marked for the garbage collector as critical and will not be touched. So no more disabling of G1, GC. Everything will be just region-based flagged, and then voila, you can go further with collecting the rest, so the latency issue is not there anymore. If you want to know more, you can find some links here. It's mostly on ZGC, but also about region pinning, so read more what region pinning means and so on. Another dear change for me, because I like security a lot, is Key Encapsulation Mechanism API. This is a new API that was introduced in JDK 21. So historically speaking, we're probably familiar with public key encryption schemes. And we know how basically those work. But these public key encryption schemes, they are vulnerable as the quantum computing advances, and I think there was a keynote on quantum computing. But you can also see sometimes research being posted that, yes, it's possible to break some of these algorithms with powerful enough computers, like quantum computers. So in order to prevent these kind of situations, the key encapsulation mechanism has been proposed as a way and its algorithms have been proposed as a way to counteract these kind of attacks. So there are a series of algorithms that work with CHEM. And they are not like the traditional cryptography methods that we know, because a key encapsulation mechanism does not require padding to create a key and so on. It uses the properties of the public key to derive a related symmetric key. And another thing that you should know is that CHEM first is transmitting the shared symmetric key and later uses it to encrypt the data using the symmetric algorithm. So it has two steps unlike the other one. This API has a few parts. So the key pair generation function was already there in the JDK, still using the key pair generator API. What's new with the CHEM is that there's key encapsulation and a key decapsulation. So the key encapsulation is called by the sender, takes a public key as input and outputs a shared secret value, the encapsulation. And the decapsulation function takes the as input that the encapsulation did before, and the private key, and outputs again the shared secret value. So what both the sender and the receiver make sure that they share the key in order to access the content further. If you want to know more, there are a few videos on it. There's an API, and recently, I think there was something written as well. And next one that I want to give and bring to your attention for the part of performance is looking at the improvements from Project Loom. So probably, let me ask, have you heard about virtual threads? Can you please raise your hands? Good, that's great. I'm not going to go through this too much. Amazing. So probably you already know how virtual threads are working. There's a lot of material all over the place. So it's great that the audience is already knowing this. But some advantages that I love about virtual threads is that besides performance aspects and so on, you also get readable code and maintainable code with virtual threads. And you can inspect better the connections that are between parent and children threads that respond there. Another thing that I love about virtual threads is because they're really, really adopted within the ecosystem. Became really loved since the feature was in preview states. So you can see here some frameworks that already adopted them, that they provide references and so on. And if you want to know more in depth, of course, there are videos. There's a JVMLS nice presentation from Alan Bateman from Virtual Threads, and of course the JEP that was finalized for JDK 21. The beauty of virtual threads, well, you can create many virtual threads, that's great. But you also need to control them, right? You need some control over that. So structured concurrency is there to help with the control part over that. And in case of my application, I use structured concurrency for several cases. So for one thing, I said, okay, for a present, I want to get the present really fast. So I want to get the present offerings really fast. And I have 4 offers, 4 possible vendors that could offer me presents. And what I did in this case, I want to get the fastest present. So the first vendor that gives me a present is the winner. So in this case, I'm reading the offer from vendors, like all those offer 1, offer 2, offer 3, and so on. Then I'm joining that to wait for at least one task to be there. And when at least one task is there, I'm getting the result of that task. I'm shutting down the rest. I don't care about the rest if they're doing something. That's it. I got my present fast, and then that's all with there. Now, this is a very nice feature, a nice advantage of what's going on there. So I get a present really fast. What this gets is that applications that have high concurrent requests, but have fewer CPU operations, and threads spending significant time just waiting, they can take advantage of this kind of model and will have higher throughput with virtual threads. That's the importance of it. Now, the another aspect of structured concurrency is scoped values. So in the case of an experience record, I thought hey, maybe I should not process and give informations unless there's a valid request, right? So I want to first check there's a valid request, then get the experience. And in this case, I want to get the cheapest, I think the best in price experience was the cheapest experience in that case. So in this case, the offer that is going to be returned here is going to be the one that has the cheapest price or something like this. I remember exactly, the cheapest price. So yeah, this is a way to actually utilize the structured concurrency and of course scopes, where value scopes. This is where you can find out more about what I told you earlier with structured concurrency. And let's go to the futuristic part of the presentation, exploring new horizons. Talk about 2 projects. First of all, Project Leiden, briefly touching it. There are presentations from DevOps Belgium, was the most recent one, that was done by Brian Gutz, that goes in depth of Project Leiden. But what Project Leiden is about, improving the startup and warm-up of Java applications. So this includes work done by the application or work done on behalf of the application. So for example, like parsing configuration files would be done, work done by application, and work done on behalf of the application would be loading and compiling classes. And looking into the future to improve the startup and warm-up, there are several experiments and research about shifting computation with what is available right now in Java. And you can shift computation in several ways. By either shifting computation later in time or earlier in time, well, lazy techniques, or earlier in time from shifting computation from runtime to build time. And probably you have experienced different frameworks that some of them handle a lot of work when they build, some of them had a lot of work when they were running them. But the nice thing is that this project aims to shift computation in a way that take advantage of what is available in Java. So for example, use the normal Java semantics of programs, like compile time constant folding, that's shifting earlier. Garbage collector comes a little later, of course. Or you to enable that. So like you have control about how the shift of computation will be happening. So for example, like IoT or CDS. So Leiden, in a nutshell, means that it will shift computation later in time in the hope that it won't be necessary to shift that computation maybe, earlier in time from runtime to build time, or introduce a spectrum of new constraints, of optional constraints on the computation. So the idea is that to shift computation selectively, but also have have compatibility, most of it, because you don't want to change entirely your application just to take advantage of better startup and warm-up, right? And that's something that Java is known for backwards compatibility strength. There's light in progress, so I gathered some links to existing experiments. So there are some branches, some draft jobs where you can read more about what's going on in Leiden, and more information is about the concepts that I briefly captured in the slides because it would be too much to just cover Leiden. There's a talk from JVM Language Summit where Mark Reinhold has shared more about Leiden, but also shared an experimental project called SpringPad Clinic using some of those research branches and comparing the results on there. That presentation is available as well in a public space, and I think I captured that one in the link as well. But another part that I want to share, another project, also to think of the future, is Babylon. Babylon has the primary goal to extend the reach of Java to foreign programming models such as SQL, differentiable programming, machine learning, and GPUs. So the idea is that Babylon will reach to these foreign programming models with an enhancement to reflective programming in Java, code reflection. And some of you are like, okay, wasn't there a reflection API? Well, code reflection consists of 3 parts. So the idea of modeling Java programs as code models suitable for access, analysis, and transformation. Then the enhancements to the Java reflection enable the access to code models at the compile time and runtime. And then, of course, Babylon thinks about APIs that you could use to build, analyze, and transform these code models. It would be a uniform way via APIs. But the experts of this, I gathered some videos and some presentation. The expert is Paul Sandoz, the initiator of this project. And you can get more info from what's going on there and follow the discussion that started in September 2023 on OpenJDK Mail. And of course, be involved in that one as well. But if you want to stay tuned all the time with the latest news, what's going on in Java and so on, we have 3 ways to engage you with that. So the first one is dev.java, the website where you can find tutorials with Java. It's good to have a refresh from time to time with simpler or more complex subjects. But I assume that in the audience are also like senior developers, so you are welcome to contribute to dev.java. We love to have contributions from the community to gain insights from you, gain a fresh perspective, and have you contribute to dev.java in writing as well. You can contact me after the talk and I can give you details of where you find the contribution guidelines and more. Inside.java is the website where we aim to publish news of what's going on in Java, where we publish different research articles that we're doing with Java language features, or anything that we consider as noteworthy for you to be up to date and get it first, so that you can know what's going on with Java and see what's going on there and not be surprised later on, learning it from other news that happened. And sometimes, as some of the concepts that happen within certain JEPs or features are more complex to digest just by reading the JEP and so on, we do certain videos aimed for different audience. Sometimes my colleague Jose is cracking the Java code interview, I think, or something like this, for helping you to, go on with Java interviews successfully. So we publish a lot of videos aimed to help you understand the features, understand Java, and help you to be better at your job or gaining a better job in the future. So follow our YouTube channel as well. Those 3 parts are there. And thank you. I hope I have some time for questions. And there's the code and the slides. If you get the slides, you get the code as well. So just gaining the slides is enough to get the code at the end. But the code is public anyway, so no problem there. So take pictures, waiting for questions, stop me in the hallway. I'm going to be the whole day here. Looking forward to talking to you. No question? Okay, there's a question. Yes.
Are there any plans on further enhancing records? Like, for example, I like to use records because I like to use immutability in my programs. But sometimes I need to change this one property. And like in Scala case classes, they have this copy method where you can just say, okay, give me a copy of the whole thing, but just change this property.
All the changes on records and Ember project are published on the Ember page. So there is where you can find the latest news. There's nothing more futuristic that I can comment upon more. But if there's anything to be published or changed, that's going to be where it reaches. There's going to be conversations, of course, on the OpenJDK mailing list, because changes do not occur just out of thin air. First, you discuss them with everybody, and then changes will occur. So if you're on the OpenJDK mailing list, just be aware of what's going on there. I'm not a fortune teller for everything. Yes?
Sorry, excuse me. You didn't discuss much Valhalla. What's the state of affairs with that? Sorry, was that the wrong question?
There's no wrong question. It's just that, as I said earlier, I cannot foresee the future more than that is already published there for the public availability. So, yeah. Any other question? Yes.
Do you have some programming examples about Babylon? Because there was just some dashboards, but...
So Babylon was just announced in September. There are conversations going on about it. Usually projects are firstly discussed intensely, and research is conducted before examples to be thrown out there. So usually there's research, so there's conversation, there's research, and then you see something more touchable. Yes? It's there in the slides.
It explains what Embark and Valhalla and Babylon and Lilliput and Nightmare do. Use not concept Java. It's a Java newscast. All your questions are answered there.
Yes. Shameless plug for Nikolai's videos.
I know it's strange, I wouldn't do this, but my 3 questions I had.
No, he's going to give a talk tomorrow, so please go to his talk as well, and stop him on the floor as well, talk more about that. Yep. Any more questions? If somebody raises the hand, please raise it upward so I can see. Or we can talk in private afterwards. Not recorded. Thank you.